Right, well, another Banggood kit time. It's the 6th of May 2018, and that noise is Alexa powering up. I've got one of these Echo Show things, which I'm not sure about, but that's a different story. Anyway, she'll say hello in a minute, and I'm not going to reply. She keeps saying that.
Hello.
Yeah, there you go. Now, a little while ago, until recently, fidget spinners are all the rage. These spinning fidgety things that people seem to get very excited about. And, well, of course, Banggood came up with their own version. And here it is. We have a circuit board in the shape of a fidget spinner and 2 outer casings, again, as is always the case. Clear acrylic plastic covered in protective paper, which will peel off some time. It comes, as you can see, with a ball bearing for the centre, plastic finger and thumb pads, 2 battery holders, interestingly enough. So this requires 2 batteries, which I believe will, there you go, attach on the outer edges of the spinner, no doubt representing weights in order for the thing to spin, because without some heft either end of the spinner, it ain't going to spin. And of course we are talking about LEDs, so there's some LEDs. Let's get these out and have a little look. They're all surface mount. Everything on this board is surface mount. In fact, we have, let's get everything out of the bag. That's the easiest thing. So there's the thumb holders, or whatever you want to call them. There is the bearing, which seems to spin quite freely, quite nicely. A 1 metal battery holder, 2 metal battery holders. We have some, these LEDs, resistors, I think those are resistors. Surface mount, all the same value, 1, 2, 1. No resistors or capacitors? No, I think they're going to be resistors. LEDs, the square type with the notch cut out at one corner. So that's signifying, that notch there signifies where the cathode is. A bit of hardware, let's refocus that, and a pretty small chip, controller chip. And we have a push to make switch, which I'm guessing will, on each press, give a different display on the LEDs. I don't know is the answer, because I haven't looked at the instructions. And as I say, there's some hardware, just 2 nuts, 2 bolts. So it's a fairly straightforward kit. Not a great deal to it. As I say, that's the main board. So there's the chip. We're going to be fitting our LEDs along here, and our resistors along there, and that I would imagine is where the switch goes. Yeah. So let me get set up with the soldering iron and all the rest of it, and we'll give this one a go. Right, now we are actually suffering a heat wave in the UK. I say suffering, it's very, very unusual for us to have the sorts of temperatures we're getting at the moment. As I say, it's the 6th of May 2018 and it's 21 Celsius at 7:15 at night. Very, very unusual. Mind you, we're going back to normality, I think, very soon. So the temperatures will be back down to something like 15 degrees, I suppose. But in the meantime, we're enjoying the warmth. So we're going to start off with the little chip, controller chip, which we have here. And as is the case, you'll probably see, I zoom in, a little dot on the chip, and that corresponds with the notch on the circuit board screen print. So that is the position in which it will be attached. So what I'm going to do is, as always, I'm going to apply a tiny bit of solder into one of the pads like that. And then I am going to, and trying to do this behind the camera is a ruddy nightmare. There we go. Let's have a look. So I've got one of the pins soldered in. I just want to move it over very slightly. So now it should be relatively easy just to solder all the other pins in position with that one pin there holding it in place while I do so. So that's the idea, just solder one pin very delicately, don't need a lot of solder, not for something this size, and just dab it on. So I'm going to do just that now, and this is extremely difficult. I need to bear with me. Right, I had to change glasses there. My eyesight is completely and utterly bloody useless. So I had to change to my reading glasses. Let me zoom out a bit, you get the idea at any rate. So let's solder all of these pins in place. Always a good idea to clean the tip of your soldering iron after each soldering exercise. At least that's my theory. That's what works for me. And by the way, I'm not. My professional life has absolutely nothing to do with electronics. I'm desk bound, pushing paper. And as I say, electronics don't come into my profession at all. So I am 100% an amateur at everything that I do, including soldering. But the trick is, with small surface mount components like this, in my view, is A, don't use too much solder, and B, use a fairly fine point tip on your soldering iron, and C, use very thin solder. This stuff is very, very thin. It's quite old as well. I've had this for years. I've got tons of it. It'll last me until I peg it, pretty sure. So yeah, so let's have a look at the condition of that, so we can put a bit more light on the subject. And let's have a look at the condition of those soldering points. So yeah, not too bad. Even managed to get the chip the right way around, so that's good. Right, I think the next thing we'll do is we will have a look at these resistors, which are tinier than a grain of rice, mega tiny. Don't quite know why you use such tiny ones for these kits. I suppose they must be relatively cheap, because they, I'm sure, are produced by their tens of millions on rolls of or strips of like this. This is just a tiny portion, I'm sure, of a massive roll of these chips, these resistors. So similarly to the chip, I'm going to start off by just soldering one pad and placing a blob of solder on each pad. Clean the tip of the iron. Grab one of the components with my extremely crappy tweezers, and you see what's going on, hopefully. I'm conscious of the fact I might be there we go. And then once you got one end of the let's zoom in a bit. Once you got one end of the component soldered, then just hold on top of it with your tweezers, reheat the solder, and it will flatten it right down to the board, and so that side's now ready for soldering. Right, before I lose all of these, let's do the same with the other two. Looks like they provided 4, but you only need 3. That's good. These things are so tiny, the opportunity to lose one is actually extremely high. Come on. I don't know what value these are. As I say, the number on them is 121. Is that 1.2k? I don't know. Probably not. There we go. I think that one went in. I don't think these are in very, very straight at all. In fact, that last one. Oh, look, they're all a bit chunky there, aren't they? We've got some solder peaks. They're not straight. Phew. Told you I was an amateur. What can I do? So I'm using the camera to complete cock that up, didn't I? You see all the mistakes, all the flaws. Nothing hidden on this channel. Good and bad, warts and all. Right, I don't care if they're not straight, as long as they're not shorting out and they are connecting to the right pads. That's all that matters as far as I'm concerned. Right, here we go. One, two, 3. And that's those resistors soldered in with a nice peak on that one. Lovely. I can get rid of that. I don't like that. That's annoying me. Yeah. Peak has gone. So, right, so everything's looking okay there. So I'm thinking the next thing to do is these guys. So we need 1, 2, 3, 4, 5, 6, 7 LEDs, and we are supplied with 1, 2, 3, 4, 5, 6, 7, 8. So we have a spare. So that all's good. So let's get 7 of these out. I don't know what colour they are. It might be that they're multicoloured LEDs. I must also say that the price of this kit was about £3. That's probably about, I don't know, $4, something like that, under $4. Just apocalyptically cheap. No complaints at all about price of Banggood. Very rarely. Okay, so we have these chips. Oops. Losing one. And as you can see there is a notch cut out there. That indicates the cathode. So the cathode is this side, not this side. This side is the cathode, which means, if you look at the board, cathode goes this side. So all of the notches will be on this side of the board. So let's put one in, and you'll see what I mean. Now how am I going to do this? Because I think these must be multicoloured. And I'll tell you for why, because you've got 6 connectors on each LED. So it's going to be powering up the different coloured LEDs separately depending on what instructions they're getting from that chip. So yeah, I reckon these are going to be multicoloured. So what I'm going to do is I'm going to install these in a similar way I did to the chip. So put a bit of solder on one. The only problem is that unlike the D chip, you can see that the legs that you have to work with on these are just so tiny. There you go, you can see the back of it there. I mean, that is very difficult to solder. Very difficult. But we will give it a go. Right, sorry, I had a quick break there because a cup of tea arrived, and in the UK, everything stops for tea. So with that, we're going to start soldering these LEDs into place. So let's get the first one. Like I said, what you need to do is solder one pad, and then we can solder the LED onto it, noting the polarization. So we've got the corner, I don't know if you can see that actually, possibly not, but the cutout, or the notch if you like, indicating where the cathode is there, and offer up the chip to it, try and straighten it out a bit, and hopefully, yep, that looks like it's lined up quite neatly. So as always, press down on the chip, press the reflow it, and that makes sure that all the connectors are flush against the solder pads. So there we go, that's what we do there. And now I shall just solder each of the remaining connectors for this particular one and do the same for the other LEDs. Don't think you need to watch me do that, you get the idea. So let me install all of those LEDs while I lose my voice, and I'll be back. Well, I was wrong about them being CR1220s, they're far too small. What I do have is these rather cheap, nasty CR2032s, which, that's a 2016 that's just fallen out there. I'm just trying to think, I've got 2032s and 2025s. I'm going to go with 2025. The 2032s are a bit thicker. So let's see what happens. Stick one in there. That seems to slide in okay. Stick one in there. And there we have it. And it's lit up. It's lit up. Oh, I was going to say, it seems to be... Let me switch the lights off and see if I can darken it down, but you can see there, it is buzzing away. Now, I have no idea whether I can get this thing to look any good while it's spinning on this camera. So I'm going to give it a go, but you can see a bit me there, sunburnt, not a pretty sight. Okay, so let's spin this and see what happens. Oh, it's awfully long. Ugh. No, that ain't working at all. It's spinning, but it's so, I've done something wrong. I must have done something wrong. Right, the electronics are working. There's no two ways about that. It's just an on-off push switch there. I'm just, sorry, you're not seeing anything. So on-off push switch like that. So that works. So the electronics are fine, everything's fine. This doesn't make any sense at all. Sorry, you're not seeing anything here. I've got to be more mindful of what I'm showing. The bearing is just not staying in the housing. I mean, what's the point in that? That just, oh, it's fallen out altogether now. Look at that. I've either constructed this wrong, which I don't think I have, or that's just a crap design. Let me go and do some homework. Well, I think the only conclusion that I've come to with this is that somehow I have got to either glue or solder the ball bearing to the PCB and the acrylic shell. That's the only way this is going to work. Because I've got the soldering iron out and it's hot, I'm going to attempt to try soldering it, because gluing it would mean getting some pretty tough glue, which I have got, mixing it up and waiting 24 hours for it to set and all that sort of stuff, and I'm not really in the mood for that. I want to get on with the next project. So I'm going to have to get the acrylic shell off, because if I don't, that is going to most definitely melt while I'm soldering the ball bearing onto the board. Right, so if I fit what I'm not sure about is how deep that should be. That looks about right there. If I sort of wedge one of the, I reckon that's about the right height. How this will solder, I have no idea, because again, we were talking about all the difficulties I had with soldering the battery connectors on, because I'm just not very good at doing that, because it acted as a heat sink, or certainly this ball bearing is going to act as a heat sink. There's no two ways about it. So let's start off by applying a load of solder and see if it will take onto the bearing. And the answer is no. I'll try again. I think the answer is I've got to leave the soldering iron there for quite a while. For it to flow a little. Oops. And I have no idea. I don't think that is taken at all. Let me have a play and see how I get on. Right, well, I've finished my soldering of the bearing onto the main board. So have a look at what I've done. That's actually the underside. The soldering was actually done on this side, and you can see I've used a ton of solder just to get it to grip. In fact, I could probably put some more there, but that'll do for now, just to test this out. But yeah, I had to put a lot of solder on there. The bearing acts as a heat sink, so the whole thing had to get really hot in order for any chance of the solder flowing. In fact, it did flow right through to the underside as well. So I'm hoping that that is now solidly in there, which I think it is. So with that, we can now go back to installing the case to where it was before and putting the nuts in. As I said, I used an awful lot of solder to do that, and you've got to allow the soldering iron to heat up the bearing as well, because you're just going to have all sorts of trouble getting the solder to stick. So you've got to take your time over it. And as I say, I used probably an excessive amount of solder, but I think it's worked. So get my screwdriver. Oh, knock the camera over while I'm doing it. Tighten up the nuts. There and there. Oh. There we go. And put the plastic caps in. It does mean that it's standing fairly proud on one side. Quite a bit proud actually, but that's okay. It spins just fine. So, does it still work? All that heat applied, I haven't even tried it, there we go. Yes, it does. So I suppose the next thing to do is to see if we can show you this thing in action. Now it seems to me that the easiest thing to do would be just to leave it on the deck and just let it spin. So let's see. Now, something shot out there. Ugh, one of the batteries shot out. But interestingly enough, it's still going. So it only needs one battery to function. Right, where did that battery go? What I'm going to do is I'm going to bend those tabs down a little bit so it holds the battery a bit more firmly. Let's switch it off first. Yeah, so let's see if that does the trick, and we'll try again. It's still shot out. There you go. And it's dancing about all over the place. Well, you get the idea. Let's see if I can get it to go a bit faster. I have to say, that is very, very pretty. Very pretty. And that works. It's very, very effective. I don't think you're going to get the effect on the camera, frankly. But it's working very nicely. Interestingly enough, and there you go, it's giving us different patterns and God knows what else. And it's operating quite happily on one battery. And I was thinking 2 batteries were probably needed, so it's got an equal amount of weight at either end of the spinner. Otherwise it could spin out of balance, but that doesn't seem to be an issue at all. I can't feel any unnecessary vibration. But yeah, so there you go. Actually, you can see that oscillation there. That is probably because it's only got one battery in it. The other one keeps on bloody well shooting out. Stupid thing. I shall have to see if I can't jam it in there. One moment. Right, I managed to bend the battery terminal tabs down a lot more, and that seems to be holding the battery in now, but I suspect it will. And now it's not oscillating, so yeah, it does need both batteries in there just to balance out the weight. But yeah, it's really effective. Very pretty. So there you go. That's a fidget spinner. If you cut and paste the heading of this video into Banggood, then without the word Banggood on the far left, then you'll be able to find it. And as I said, it was only about £3. Very, very cheap. Effective, bright, colourful, and a bit of fun. Nice evenings project to while away those evenings when you need to while them away. I've done this on one of the hottest days of the year. Why am I spending my time inside doing this? Never mind. There you go. I hope you enjoyed it. and a few more kits on the way. And I shall do videos of those in due course. Not uploading too often at the moment because quite busy with this, that and the other. But I will try and keep the videos coming. So here we go. That's the fidget spinner. LEDs, little microcontroller, 3 resistors, push to make switch, couple of batteries, a bearing, and wallop. There you go. £3 off of Banggood. What's that? $4. Enjoy. Cheers for now.